Hello class, this is Miss Jacoy. So this is actually going to be not a full introduction video. I'll be coming out with one of those for this weekend so you have more time because the introduction was going longer than I wanted to give you for homework tonight. So today I'm just going to talk about more about the magnetic force and the right hand rule to reiterate what we're doing in class and to look forward into what we are going to be doing tomorrow. Alright, so remember the crosses mean it is going into the page, the dots mean it is going out. So this would be, you would point your fingers to the page. And this one you would point your fingers to the sky. Alright, so that's the first thing. So when you are tackling a problem, remember you are going to have some sort of field and first determine which direction it is. And remember these all stand for B, which is your magnetic field. I'm going to rewrite that was terribly written. Alright, the next on these you're going to have some sort of charge, either positive or negative. Take note of it, and then it's going to have some velocity and direction. So this is your velocity. And this is going to be point your thumb in this direction. So in this case, your fingers would be pointing down, and your thumb would be pointing in the direction, so you'd be sticking your fingernails on your desk or on your paper with your thumb pointing to the right. If you orient your hand in that direction, I'm going to try to draw a hand. You're going to see your little fingers are touching your desk. Sorry, it's really not a good picture. So you can see that your palm, this is the back of your hand, this is your palm. Your palm would be facing up. The palm is going to be the side that you're going to look to for your positive. The back is going to be the side that you look to if it's negative. Since it is positive, you're going to look at your palm side. Your palm side is up or facing this direction. So your force is going to be up. Alright, so I'm going to give you one to try on your own. Alright, so find the force on both of these, then come back for the answer. Alright, so now that you've tried it on your own, remember for the first one, your fingers are going to point in, and your thumb is going to point right. If you do this, and since it's positive, your palm will face up. Since your palm is facing up, your force will be up. Alright, and then the next one, it is facing out of the page, so your fingers should face out. Your thumb should face down. Alright, and it's negative, which means you want to look at the back of your hand, which if you twist your hand around a little bit, you will see that the back of your hand, if you point your fingers out, your thumb down, hopefully you're doing this, the back of your hand will be to the right. So the force would be to the right. So then we're going to actually start solving. Remember today we talked that this is the magnetic force. Since it is a force, it is still measured in newtons. Your Q is a charge. Oops, I didn't need to write Q. Your Q is a charge. and like all charges, it is measured in coulombs, or C. Then you have a velocity. This is in meters per second. And then you have, last but not least, B, which is your magnetic field. Your magnetic field, like many fields, is measured in Teslas. And then sine is just sine of your angle of the movement of your charge to your field. Most times they're going to be perpendicular to each other, like what we've been doing, which means that your angle will be 90 degrees. Alright, so let's try a problem. Alright, so first step, read over the problem. Just try this on your own, see if you can figure it out. Alright, so now that you've read over it, kind of thought about it, tried it maybe. So it's determine the magnetic force on a 4 microcoulomb charge moving at a speed of 90 meters per second, perpendicular to a 4,000 Tesla magnetic field. So, good news is, the one we are looking for is already alone, isolated. This is good. Then we need to start labeling our charges. So our charge, you can see here, it's 4 microcoulombs. We don't want it to be in microcoulombs. This little micro sign means that it's times 10 to the negative 6. So all this means is 4 times 10 to the negative 6 normal coulombs. So that is the number you're going to want to use. Alright, and remember speed is just another, or velocity. Speed is a type of velocity. Velocity just has more information because it tells the direction. So by saying it's moving perpendicular, that tells the direction. So that's 90 meters per second. Our B is our magnetic field. So our B is 4,000 Teslas. And then our angle, if it's perpendicular, our angle is 90 degrees. So now just plug all of these numbers in. So that's 4 times 10 to the negative 6 for the micro coulombs, 90 meters per second, times 4,000 Teslas, times the sine of 90. And then all you would need to do is plug this into your calculator. If you did that, you would get 1.44. Remember, it's a force, so it should be in newtons. Alright, hopefully this was informative. We will continue going over forces and direction. Oh, right, one last thing. So we know now how much the force is, but we don't know the direction. However, the direction is not always determinable because this problem does not tell us which direction the charge is moving, only that it's perpendicular. However, if it said this charge was, say, moving to the right, so you'd have it's positive, charge moving to the right at a speed of 90 meters per second, and if it said the magnetic field, say, for example, inward, you would know that if you did this, your force would also be up. Alright, again, hopefully it's helpful. We will continue this discussion tomorrow.